Okay, so let's talk about AI. And I mean, really talk about it. Forget the killer robots. Forget the sci-fi stuff for a second. We're going to cut right through all that hype and get to what's real. What is AI right now? How does it actually work? And where is this whole thing heading?
Okay, so first things first, let's just separate the myth from the reality here, because when you hear that term AI, what's the first thing that pops into your head? Probably some self aware robot from a movie, right? But the actual reality of AI, well, it's a lot quieter, way more practical, and it's already like completely woven into your daily life.
And this is probably the single most important thing to get right off the bat. Every single AI you use today, Siri, Alexa, the thing that recommends your next Netflix binge, that's all what we call weak AI, or artificial narrow intelligence. It's an absolute genius at one specific job, and that's it. Now, that other kind, strong AI, the one that can actually think and reason like a person, that is still, for now at least, completely in the realm of science fiction.
I love this quote because it just nails the concept. Today's AI is just simulating intelligence for one particular purpose. I mean, think about it. Your GPS is a wizard at finding the fastest way home, right? But it has zero concept, zero understanding of how frustrating it is to be stuck in traffic. It's just a really, really powerful simulation. It's not actually thinking.
All right, so let's clear something up. You hear all these buzzwords thrown around all the time, right? AI, machine learning, deep learning. They kind of get used interchangeably, but they're not the same thing. There's actually a really simple way to understand how they all fit together. The easiest way to think about it is like one of those Russian nesting dolls. You've got the big doll on the outside, that's artificial intelligence. It's the whole big idea. You open it up, and inside you find a machine learning. That's the main method we use to create AI. And then you open that one up, and inside you find deep learning. That's the powerful engine, a very specific type of machine learning that's driving all the crazy stuff we see today. So when you hear people talking about the big AI revolution, what they're really talking about are these huge leaps forward in machine learning and deep learning. So you might be wondering, how did we even get here? Well, let me tell you, it was not a straight line. The journey of AI has been this wild roller coaster of huge hype, massive promises, and then some really, really deep disappointments. It all started with ideas, like Alan Turing's famous imitation game back in 1950. Then the field got its official name in '56. By the '80s, we saw the first real-world uses with these things called expert systems, which saved companies a ton of money. But the moment that really grabbed the world's attention was 1997. That's when IBM's Deep Blue beat the world chess champion Garry Kasparov. But here's the thing you have to understand. This wasn't some kind of creative, human-like thinking. It was pure, raw, brute force math. Deep Blue was just crunching 200 million possible moves every single second. Mind-blowing, but not true intelligence.
But that ambition, it often led to these huge letdowns. There would be these periods of insane hype, and then nothing. Progress would just hit a wall. And this led to what everyone in the field calls the AI winters, times when all the funding just vanished and nobody wanted to talk about AI anymore. And you know what caused those winters? It was actually pretty simple. The ideas, the algorithms, they were brilliant, that they were decades ahead of the computers we had. The ambition was there, but the horsepower just wasn't. The reason we're in what people are calling an AI spring right now is because two things finally clicked into place. One, our computing power has exploded, mostly thanks to gaming chips, GPUs. And two, we now have the internet, which means we have unimaginable amounts of data to feed these hungry algorithms.
Okay, so that brings us to today. And what's super interesting is when you peek under the hood of the tools we're all using, things like ChatGPT or Midjourney, you start to see that it's not just one magic AI doing everything. It's not one size fits all at all.
Right now, there are really two kings of the generative AI world. On one side, you've got transformers. These are the engines behind large language models, LLMs, think ChatGPT. They are absolute masters of understanding context in language and code. They're the writers. Then, on the other side, you have GANs. Think of these as the artists. They are the gold standard for creating unbelievably realistic images and videos. So you've got your writers and your artists, different tools for very different creative jobs.
But AI isn't just about making stuff like text or images. It's also about doing stuff, taking action. And that's where something called reinforcement learning comes in. The best way to think about it is, imagine teaching an AI to play a video game. You don't give it a rule book. You just tell it, get a high score. And then you let it play against itself millions of times.
It learns from every single mistake, through pure trial and error, until it's unbeatable. That's reinforcement learning, and that's the tech that's going to power the next wave of things like self-driving cars and advanced robots. Okay, so with all this incredible power, obviously comes a huge amount of responsibility, right? And that's led to the world's first real major attempt to put some rules around this stuff. It's a big deal, and it's setting the tone for the rest of the world. So the European Union created something called the AI Act, and the way it works is like a pyramid based on risk. Let's start right at the very top. This is the unacceptable risk category. These are AIs that are considered so dangerous to people's rights that they are just banned, flat out. We're talking about things like government social scoring systems or AI that could manipulate vulnerable people. Just nope, not allowed.
Okay, take one step down the pyramid, and you get to the high-risk stuff. Now, these systems aren't banned, but they are heavily regulated. This is AI that's used in really critical areas, like in medical devices or making decisions about who gets a loan or in law enforcement. To operate, they have to prove they're using high-quality data, that a human is always in the loop, and that they're super secure.
Then we have the limited risk tier. And for these, the rule is actually really, really simple. You just have to be transparent. If you're talking to a chatbot, you need to know it's a chatbot. If you're looking at a deep fake, you need to be told it's a deep fake. It's a simple idea, no deception, but it's absolutely essential if we're going to trust these systems.
And finally, we get to the bottom of the pyramid, the minimal risk category. And this, believe it or not, is where the vast majority of AI applications live. Think about the AI that filters your spam email or the enemies in a video game. This stuff is pretty much left unregulated, and that's on purpose, to let people innovate and build cool things without being bogged down by a ton of rules. So this whole new world of super powerful AI and all these new rules, it forces us to kind of step back and ask a really basic question. If the goal isn't to build a sci-fi robot anymore, then how do we even know if an AI is good or intelligent?
You see, for decades, the big test was the Turing test. Could a machine fool a person into thinking it was human? But honestly, that test is completely obsolete now. It's irrelevant. Why? Because today's language models are so good at just mimicking human conversation that passing the test doesn't really mean anything anymore. And we've learned a crucial lesson. Just being able to imitate intelligence is not the same thing as actually having it.
And that has led to this massive shift in what the goal of AI even is. The new benchmark, the new way we measure success, isn't about imitation anymore. It's about one simple word: utility. Can it actually solve a real-world problem? Can it help a scientist cure a disease? Can it create real value? The question has changed from, can it trick us, to can it help us?
And that really leaves us with one final and kind of huge question to think about. We are, without a doubt, building one of the most powerful tools our species has ever created. So if the new goal is utility, if the goal is to solve real problems, what problems should we point it at first?